In this video, we're going to do two examples of solving a system of linear inequalities. Okay, so here's our first system. This is called a system because there are two inequalities, and since it is a system, we're going to graph these on the same coordinate plane. Now, what does it mean to solve? It means to find all of the points that would make both of these inequalities true. All right, so in general, if you're solving a system like this, you're going to have two boundary lines, and we've seen that some of them can be solid, some of them can be shaded. And we're only going to look at the ones that do intersect like this. There are other situations, but we'll keep it to just these. And then we've also seen for inequalities that you shade the points to one side or the other that represent solutions to that inequality. All right, so maybe for the dotted line one, maybe all of the points that make that inequality true are on this side, and then maybe for the solid one, maybe the points all fall on this side. Right? And so then if you look for points that solve both inequalities, you're just looking for where the shading overlaps. So in this example, the ones that are shaded orange and blue would make both inequalities true. And we can check that as we go, confirm that with a test point. Okay, so how do we actually solve and graph these? Well, we're going to use the same method that we did before when we talked about graphing a single inequality, and we're just going to repeat it twice to solve both of these. So let's look at the first one. X plus 3y is greater than or equal to 6. Right? Let me demonstrate the points method for graphing this one, and then I'll do y equals mx plus b on the next one. Alright, so you want to look at the boundary line x plus 3y equals 6, and let's say you're looking for the intercept points. Okay, then you're going to plug in 0 for x and try to solve and figure out what y is. Okay, so in that case we'd have 0 plus 3y equals 6, and then solving for y, we see y is 2. So that would be the point 0, 2. And then you would just repeat and do the same thing, but this time substitute a 0 for y. And then this time you get x equals 6. So that would be the point 6, 0. Okay, so then we have 2 points. Here's 0, 2. And here's 6, 0. And then we can connect those with a line. Now we did talk about the boundary line, whether or not it is solid or dotted. So in this case, since we have a greater than or equal to sign, we do want to graph also points where x plus 3y is equal to 6. Okay, either where they're greater than 6 or where they're less than 6. Okay, so then, greater than or equal to. So because of that equal sign, okay, we can include that boundary line. Okay, so there's a line that represents the first inequality. Now we need to decide which side to shade because we do need to represent all of the points where x plus 3y is greater than 6. So let's use 0, 0 as a test point since it is to one side of the line, not on it. And when you plug in 0 for x and 0 for y, then you get 0 is greater than or equal to 6, which is false. So we are not going to shade the side with 0, 0. We're going to shade the other side. Now some people like to shade now or wait till the end because we are going to have so much shading and we are looking for some overlapped shading. So another option, if you don't like that, you can just draw a little arrow that indicates which side of the line you're shading. Okay, and if I was shading the other side, you would just face your arrow the other direction. Okay, so I think I'll shade this one, and then on the next example, I'll show you the arrows. Alright, then to graph the second inequality, I might do this one by using y equals mx plus b. So I'm going to look at the boundary line, 2x minus y equals 10, and I'm going to add y to both sides, and then subtract 10. Alright, so on one side over here, you're just going to have a y, and on the other side, you would end up with 2x minus 10. So that tells us that the y-intercept is -10, and then the slope is 2, or 2 over 1, so you would go up 2 over 1, and I'm just going to repeat a couple more times to find a few more points on the line. Alright, and especially for graphing, I think that makes it easier to draw a line through those. Now we need to decide if it's dotted or solid, and this one just has a less than sign, so I don't want to actually graph points on the boundary line where we have this equal sign. Okay, just points to one side or the other. So I'm going to make that a dotted line. Alright, and then same thing to decide which side to shade. We need to choose a test point. Let's go with 0, 0 again. So when you plug in 0 for x and for y, you end up with 0 is less than 10, which is true. So I am going to shade the side with 0, 0. Oops. Yeah, that's right. Okay, so now if you look at the graph and see where we have overlapped shading, basically you have 4 regions here. So, you know, when you have 2 lines like this that are crossing, there are four different regions formed by those 2 lines. All right, so one of them in these problems is always going to have the double shading. All right, so here we have points in this region are shaded both orange and blue. So anything in there that we pick out should be a solution. Let's test one of those just to make sure. So let's go with 3, 3. That's definitely in that region. All right, so in the first inequality, substitute 3 for x and for y and see if that's true. Okay, so we end up with 3 plus 9, which is 12, and 12 is greater than or equal to 6. Then in the second inequality, 2 times 3 minus 3, and we get 6 minus 3 is 3, and that is less than 10. All right, so 3, 3 is a point that solves both of those inequalities. All right, you can choose other points, like you can choose points on this orange line, okay, because technically they are part of the orange solution, and they are also shaded blue, so that would work. You can't choose points on this blue line, like here, because even though they'll make the orange inequality true, they're not going to make the blue one true. All right, so let's test it out to make sure that that's a true statement. Here's a point. This one should work. Okay, this is 6, 2. 6, 2. And it's a little hard to see, but that is on the blue line, and it is shaded orange. Okay, but since that blue line is dotted, it should not actually solve the inequality. So let's plug it in and try it, 6, 2. And that inequality was the second one. So we'll substitute in a 6 and a 2. And we get 12 minus 2, which is 10. So notice it's close, and if we had less than or equal to, that would work. But we don't. 10 is not less than 10, okay, so that's not a solution. All right, so basically, to summarize, your solution is the overlapped shading, and then you can include things along the boundary of the overlapped shading as long as it's a solid line, but not if it's a dotted line. Okay, let's solve this one graphically. X is greater than -3, y is less than or equal to 10. So looking at the first inequality, start by looking at the boundary line, x equals -3. Now this one looks a little bit different than the last example because we don't have a y as a variable in here. So you may remember how to graph things like this. If not, you might want to try substituting in points and look for one that makes the equation true. So think about what types of points would fit in that equation. So what does x have to be? Y, it doesn't really matter since it's not in the equation. I can make that anything, right? But x cannot just be any number. So let's say I pick like a 10 for x and substitute that in. That's definitely a false equation. So the only thing that x can be to make that true is a -3. And then y can be anything you want. So let me graph some of these points. Here's -3, 0. You can do -3, 1, -3, 2, -3, 3, -3, -5, -3, -10. And when you plot all of these, all right, you should notice that they are all falling on a vertical line. So this is a fact. If you have a line that's just x equals a number, those are always going to be vertical lines. And you plot those by just going on the x-axis to where x equals whatever that number is, -3, and then you just drop a line straight through it. Okay, now this one I should have checked before I drew the line, but this should be a dotted line because it's actually x is greater than -3. Okay, so there's a dotted line. Now, which side do we shade? You can do the same thing with a test point. So let's choose 0, 0 and plug that in. Now there is no y to substitute, so you are just substituting 0 for x. All right, 0 is greater than -3. That is true, so you would shade that side. So I'm just going to draw a little arrow to indicate which side we're shading. It would be all of the points to the right of that line, and then I'll wait to shade until the end. Okay, let's look at the second inequality. Y is less than or equal to 10. So let's look at the boundary line, y equals 10. All right, so same thing, we could try to find points that make this true. And this means that the y has to be a 10, but x can be anything you want, like 0, 10, 2, 10, -3, 10. And when you start plotting these points, you're going to see that they all fall along a horizontal line. Okay, all along here. All right, so lines that look like y equals a number, these are all going to be horizontal lines, and you find them by just going on the y-axis to where y is that number, -10, and then drawing a line horizontally through there. Here's another way to think of it. When you see y equals 10, you could put this in y equals mx plus b form. This is the same thing as y equals 0x plus 10. So this would be like a line that has a y-intercept of 10, and then a slope of 0 just means it's flat. Okay, there is no rise, no run. All right, or you could think of this as no rise and then whatever run you like. So in other words, you're just moving side to side, but never up and down between points on that line. Okay, this one is less than or equal to 10, so it is a solid line, and then we just need to decide where to shade. So let's use 0, 0 as the test point again. Let's plug that number in. 0 is less than or equal to 10, that is true, so we do need to shade the side of that line that has 0, 0. Okay, so then I would compare and just follow these red arrows and shade where they are indicating. So they're telling me to stay to the right of the blue line and below the orange line. So the final solution would be all of these points in here. Okay, and notice I'm just ignoring the x and y axis when you're shading. I'm just shading in reference to the orange and blue lines. All right, points on the line, could they be solutions? Well, things along the orange one, yes, because they are still to the right of the blue line, right, and below or on the orange line. But points on this blue dotted line would not be part of the solution, okay, because that's a dotted line, it's not included. Let's test one more point just to make sure, and let's pick one that's not shaded. So let's go all the way to -6, 0. How about that one? -6, 0. All right, so to test it, let's put -6 in for x in the first equation. -6 is greater than -3, that is false. And in the second inequality, substitute 0 in for 10. All right, And that one is true. All right, so if we had just shaded below the orange line, that point would have been shaded. All right, but remember, a solution has to make both inequalities true. So it makes one false, so it can't solve the system.